so we're doing what if data tables. So let's recall that electricity generation problem we had. We wanted to minimize something like 3x squared plus 2y squared subject to x plus y greater than or equal to 4. And we could put in like 4 and 0, and then our objective function we had like a 3 and a 2. We square that, and then take the sum product of our cost coefficients with the squares. So then I could put in different values here like 2 and 2 and see what my objective function is, right? All right, so now let's try a bunch of different x values. So I could say let's try 0, and we'll just have y adapt to the x value. So it's a really simple constraint, right? If I produce 0 here, I need 4 there. If I produce 4 here, I need 0 there. So now what I can do is say, let's try these x values. How about 0? We'll do like 0.2. And we'll go up. Really, we could stop at, well, we should stop at 4, because otherwise we'll be generating negative electricity at the other one. So I lay that out. And then I'm going to put a cell here that says what my objective function value for that x value is. So I'm going to do that. I could have just done that calculation here, but it's usually nice to have the calculation done already and then just copy that value. And I don't mean copy paste, I mean live copy. All right, now it's going to be a little funny. I'm going to highlight this table, including that blank cell right there. So it looks a little off kilter. Then I go to data, and I want what if analysis. And if my screen was arranged differently, this would actually say what if. But right now it just has a question mark. You can see the little tooltip for it is what if analysis. And I want to do a data table. And it wants to know where should it take stuff from the column inputs and where should it put that in the spreadsheet. So I'm going to say, I don't have any row inputs here. I could lay this all out as a row instead of as a column. But right now it's as a column. I want it to put data from here into the x value. So it's going to pick up the 0, put it there, recalculate the whole sheet and look at this, and put the resulting value here next to the 0 that it just used. Then it'll pick up the 0.2, put it here, recalculate the whole sheet, look at this answer, and put that next to the 0.2. So it's basically a for loop, if you know programming. And it doesn't animate it, it just does it. This is a really simple problem, so it's pretty fast, but you can get, like if this calculation went on for 100,000 rows, it would take some time to fill in each little step of the data table. Notice that I can change my allocation here. Like I could put like 0.11111, and it calculates that, but it doesn't affect the data table. The data table will like, whatever x value is here, it'll put that somewhere safe, put the 0 in there, recalculate, record. It'll do all that and then put back whatever was there, kind of invisibly. So here I can say, if I've got data, I should probably graph it. No, not line, scatter. So this would be the x values that it tried and the resulting objective function. And so there's my optimal point. Now, I would like to put labels at the top of the column before I graph it, right? That's what I usually do. But if I put something here, that might mess it up. And this cell has to be a number. So I kind of put the word x values over here, and you could put results here. So it's not super convenient for graphing, but we live with it. Yeah?
Could you put x values next to results?
Yeah, you could put that there, but if I tried to graph that with the words at the top, it'll be weird because it's got a blank cell here, and it's got this number which does not relate to any of these numbers. It just depends on whatever I have there. Okay, so that's a one-dimensional data table. And I could have done all this in one cell, right? But if I had, random calculations and stuff, it might be hard to put in one cell. Actually, let's give that a try. Let's copy the sheet. So let's say I'm not a very good electric utility and I actually have some randomness to what I plan to do this, but then this other thing happens, right? So I could say this x value, let me insert some cells here. So this would be planned x value, and then actual x. And it could say take the planned x value and multiply by like 1 plus RMS inv rand times 0.03. So that would be 3% multiplicative random noise. So whatever I plan, like let's say I plan for 2, I do something close to 2, and then y makes up the difference. Okay, so now if I reformat this, or redo this data table and say to put my planned value over here, it'll try putting a 0 in there, see what actual x you get. It'll try putting a 0.2 in there. So now, because it recalculates every time, it regenerates that random number every time. So I have, actually, let me increase the noise here so it's more obvious. How about 15%? So it's doing random trials now. So any questions on this? Okay, so here I'm changing x values. I could do something similar where I'm not even changing anything, I'm just letting the randomness take over. So let's do something easy here, like I'll do rand, and we'll sum the two of them. Now I can say, what's my trial number? 1, 2, 3, like that, and put the randomness there. And so now I want to do 96 trials of just recording the sum of two random variables, two random uniforms. So now I want it to pick up the 1, put it somewhere, recalculate the spreadsheet, and then record this number. Pick up the 2, put it somewhere, recalculate the spreadsheet, look at this number, record it there. But it turns out I'm not going to use these numbers anywhere, right? So I can click on any cell in the sheet, probably other than these. Like I could just have it put numbers there, and every time it puts something there, it'll recalculate the randomness. So there it's done 96 random trials. If you're really careful about things, you would actually be using these as seeds to a random number generator that you can get the same numbers back again if you put in the same seed. That's more of a computer science thing. So you could actually be using these numbers somewhere. So that's using it to do random trials. And then what someone was doing here, we have like the 3 and the 2, right? But we could say, well, those themselves could change. Actually, let's do it this way. We can do two different things. We could say, instead of x values here, we could say, let's change the x objective function. So we could say, well, instead of 3, how about started at like 2.0, 2.1, etc. And now we want to say, try these various x values and record the results at each of these different costs for generating at station 1. So I have to say, where is this number going to go? And it actually has to go in the corner of the table here. It's kind of weird. So we should like color these one color, color those another color. This is kind of an objective. And then we're going to fill in this table. So I'm going to highlight the whole thing. And go data table. Actually, so our row input cell now, we want to say take stuff from the row and put it where?
Right.
There. Take stuff from the column and put it there. And so that has tried different x values and different costs for plant number 1. And then someone was asking about this earlier. How easy is it to read a table of numbers? Not very easy. I can highlight just the numbers in the body of the table, not the edges, and go to Home, Conditional Formatting, and choose maybe high cost is bad, so that's red, and low cost is good, so that's blue. So we can see as x gets more expensive moving this way, the lowest cost thing to do in the column keeps moving up. Send less business to x when it gets more expensive. So that's what you've learned in class this semester. When something gets more expensive, buy less of it.
So
All right.
if something's cheap, you should buy a whole bunch of them?
Oh, yeah. Yeah, that makes a lot of sense.
Penny stocks.
Yeah. All right. So that's like a 2-dimensional for loop at that point, right? Scrolling through 2 sets of values.